Hi everybody. So today we are going to be looking at something called a special right triangle. We're going to be looking at triangles that have 45, 45, and 90-degree angles in them to try to figure out some patterns for their side lengths. So first let's look at these triangles and see if we can notice anything about them. The first thing that you might notice is that they are isosceles. They have two equal angles. We know that triangles add up to be 180 degrees, so we could find those missing angles there by doing 180 minus 90 and minus 45 to get those other missing angles. The other thing that you'll see is that we've got them as isosceles because we've got matching angles here. So they each have two angles that are the same as each other. We're going to come back to that idea in a moment. And then I also want to point out that all three of these triangles are similar to each other, and they are similar to each other by angle since they have matching angles. Okay, so now I'm going to tell you one of the side lengths in each of the triangles, and we are going to see if we can figure out the other leg. Now, returning to that idea of them being isosceles, you probably know that the other leg is the exact same size. Not only are the angles the same as each other, but then the side lengths are going to match as well. So we've got the 45s that match, and then in the first example, the 1s match. In the second example, the 2s match, and then in the third example, the 3s match. So the next thing for us to figure out is the hypotenuse. There's lots of different ways that we could figure out the hypotenuse. We could try doing SOHCAHTOA since we've got an angle. We could maybe even try law of sines or law of cosines, but what we're going to use today is Pythagorean theorem. So I'm going to start by doing our Pythagorean theorem problem where we're going to add the legs together. So in the first example, we're going to do 1 squared plus 1 squared. In the second example, we'll have 2 squared plus 2 squared. And then the final example there, 3 squared plus 3 squared. So if we simplify, we're going to have 2, 8, and 18. So now we're going to use that idea of simplifying radicals in order to solve for the missing sides here. So for the first one here, when we take the square root of both sides, we're just going to get square root of 2. That's simplified all the way because 2 is a prime number. So that means that this leg is the square root of 2. Now, it might seem strange to leave it as a radical instead of making it a decimal, but we're going to do that just to try to see some patterns with these other ones here. So now let's try doing the square root of 8. So if we try to break down an 8, we can break that down into 2 times 4. And if we break that down again, the 4, we get 2 and 2. So really here, what we're going to have is a pair of 2's and then the square root of 2 left over. So this leg here is 2 square root of 2. Let's do the same thing for the square root of 18. So if we try to break down an 18, we could do 2 and 9. And if we break down 9, we'd get 3 and 3. So we've got that pair of 3's. So this is going to be the equivalent of 3 square root of 2. So hopefully you are starting to see a pattern here. Show you what this looks like, kind of all cleaned up, a little neater than my handwriting, and hopefully you're noticing a pattern. So if you notice that in this last triangle that we just looked at, the side lengths are 3 for the legs, and the hypotenuse is 3 square root of 2. In the orange one, the side lengths or the legs are 2, and the hypotenuse is 2 square root of 2. And then for the first one, the legs are 1, and this would be the same thing as 1 square root of 2. So the overall pattern for the relationship between the legs and the hypotenuse of a right triangle that's got a 45 angle and another 45-degree angle is that the first leg and the second leg are the same size. And then if you take that leg and multiply it by square root of 2, you have your hypotenuse. So here's what it looks like on a diagram. If we try and use this to figure out some of the missing sides on this triangle, we can see that we've got an isosceles right triangle here. Both angles are 45 degrees. And then the side lengths are also going to be the same. It's going to be an isosceles triangle. So this other leg here is going to be 25. And then the hypotenuse is just going to be 25 times the square root of 2. Okay, so now we're going to fill in your notes packet, your triangle toolkit that you should have from before break. So we're going to fill in the section for 45, 45, 90 triangles. This is only going to work if we've got a right triangle that's got two 45-degree angles in it. And this pattern that we're going to use is just if you know the two legs of the triangle, those are going to match. They're going to be the same size, and they're going to be equivalent to, for the hypotenuse, multiplying that same number times the square root of 2. So let's do this first example here. So we're going to see if we can figure out how big theta is first. So we know there's 180 degrees in a triangle, which means that that missing angle's got to be 45. Since we've got these two angles the same, that means these two sides are going to be the same. So A is going to equal to 10. And then B, the hypotenuse, is just 10 times the square root of 2. Then if we look at the other example here, we've got our two legs that we're going to try to figure out and our two angles that we're going to try to figure out, assuming that this is an isosceles triangle again. So that means that both of our angles here are going to be 45 degrees. And then to try to figure out what C is, this time we have the hypotenuse to start with. So we've got this 14 square root of 2. Basically, all we're going to do to get the other two legs is just remove that square root of 2, just leaving the 14. All right, if you need to pause the video to catch up on your notes, now would be a good time to do that. And then next, you're going to do some practice problems. All right, so here are a couple of practice problems for you to try. I want you to pause the video, give these problems your best try, and then go ahead and play the video to check your answers when you're ready. All right, here are the answers for you to check. We can see that in example 1, we've got an isosceles triangle. These two sides are the same size, so that's how I know that C is also 12. I know my angles are going to match as well. And then my hypotenuse is just 12 times the square root of 2. The other triangle here, it says that it's isosceles again, so that means our two side lengths are going to match. So if this is 13, that means H is also 13, so I filled that in here. And since it's isosceles, these two angles have to be the same for E and F. And then my hypotenuse is just 13 times the square root of 2. That's it. Have a great day.